You come with me here.
My name is David Malone. I am a science documentary filmmaker, and I've come to Papworth Hospital in Cambridgeshire.
So this is the first time you've been in theatre?
Yes, indeed, yes. So I don't know what I'm doing, but I'm very good at following orders.
I'm here at the invitation of consultant surgeon Mr. Francis Wells, who is going to allow me to watch him perform open heart surgery.
He's got a leaky aortic valve.
I've always wanted to see the beating human heart, that thing within us that keeps us alive.
You'll see when you get in here just how colourful the human body is. It's amazing.
You sound like it's never lost its thrill for you.
No, not at all.
The heart is unlike any other organ in the human body. It has its own rich language and poetry. Throughout history, it has been a potent symbol in our religion, literature, and philosophy. It has been seen as the site of our emotions, the very center of our being. But modern medicine has come to see the heart as just a pump, a brilliant pump, but nothing more. And we view ourselves as ruled by our heads and not our hearts.
So that's the valve actually going into place?
Going into the root, yeah.
And yet there's something about the heart that makes me wonder whether there is more to it than this.
You open up this body that's lying still, and inside there's this other creature struggling away.
So I want to explore the story of the heart, how it came to lose out in the age-old battle of hearts and minds, and ask whether, with the help of modern science, the heart may reclaim its traditional place at the center of our lives.
There's the heart working, all back in one piece.
Open heart surgery is one of the great triumphs of modern medicine.
I have to tell you, it's the movement which
Yeah.
I find extraordinary.
The liver just sits there looking ugly. The spleen sits there looking ugly. The bowel sits there smelling awfully. The brain sits there doing absolutely
Nothing at all.
To perform operations like this, surgeons can't help but view the heart as a machine, something that can be fixed when it goes wrong. But for Mr. Francis Wells, one of Britain's leading heart specialists, this is a machine that can still inspire wonder.
What we see is a bit of muscle contracting here.
Yes.
But what's going on inside the cells at a metabolic level is immensely complicated.
You work with these hearts and every day. You see
Yes.
them, the mechanical side of human nature.
Yeah. There is a mechanistic side to it, which is easily appreciable and learnable and correctable. But you rapidly appreciate that it isn't just mechanical either. Biological structures and tissues are beyond mechanical. I mean, yeah, it has a life, it has a momentum.
For Mr. Wells, the heart's extraordinary biology gives it a beauty all of its own. He sees no need to romanticize the role of the heart beyond its vital function as a pump.
Thank you.
Oh,
It was a
pleasure.
privilege.
No, not at all.
I suppose what I'm looking at is how much of that wonderful poetry, the romantic poetry of the heart, is just poetry.
All of
and
it.
how much of it is a poetic report about something that
But you
happens.
see, you've answered the question yourself, because you made the point at the beginning that you'd never seen the human heart before.
No.
And I would bet you that 99.99% of the poets in the past have never seen the human heart before. We all like this emotional interplay, but the heart is a bunch of muscles with some nerves that stimulate it, and it has some chemical receptors which allow it to respond to chemical and neurological stimuli. Whilst we all want to think of it as being this incredibly fanciful structure, and we all do, in reality, it's a pump. That's what it does. But I know I can take the heart out and you can still fall in love. I know I can take the heart and the liver out and you'll still fall in love.
Yeah.
I can take the heart, liver and lungs and bowel out and you'll still fall in love.
Well, that's useful to know in an emergency, I suppose.
Well, it's true, we've done it.
But if I ask myself, what part of me feels love for my family, I would say I feel it in my heart. I love my 3 sons with all my heart. And when I first met my wife Sarah, my heart skipped a beat. This is the familiar language of the heart, one that talks about being broken-hearted, or your heart swelling with joy. The whole reason we're making the film is to explore that poetic language of the heart. You know, his heart swelled, his heart jumped, his heart burst, his heart broke. I suppose what we're asking is, how much is that language just poetry? And how much of that poetic language is an accurate description of something which is true, just said poetically? And I don't know yet. Why this matters is because I believe our view of the heart, in some fundamental sense, is a reflection of how we see ourselves. You see, the problem I have with the modern view we have of ourselves and our world is not so much that it's soulless as heartless. We're encouraged to view ourselves as if we live just in our heads, as if our brains rode around in our bodies the way that we drive our cars. And for me, that means we relegate everything that we feel, as if somehow our emotions were less important than our thoughts. Yet for much of human history, we saw that what made us wonderful creatures was not our brain, but our heart. But was this very different way in which we used to see ourselves so misguided? Richard Parkinson is a curator at the British Museum and is showing me a papyrus over 4,000 years old from ancient Egypt.
This is the famous papyrus of Ani, which is part of one of the funeral papyri.
For the ancient Egyptians, the heart was the most important organ in the human body.
It's very much the symbol of the mind, the emotions, the character. Everything is represented by that particular organ.
And did the ancient Egyptians believe that that was the centre of their being?
It seems to be that way. All the language refers to the heart in descriptions of character. If you're greedy, you are grasping of heart. If you're patient, you're enduring of heart. Right. The heart is the one thing that really anchors all ideas of personality.
The papyrus depicts a scene called the weighing of the heart. The ancient Egyptians believed that a person would only pass into the afterlife if their heart balanced against the feather of truth. If not, the heart would be eaten by the devourer and they would become nothing.
Why balanced against truth? It's lovely. I mean, it's lovely.
Truth is the Egyptian way of life. It's something like justice, truth, order in society, in the personal life, in the cosmic life as well. And your heart has to be exactly in a tune with Ma'at, with truth.
With that truth.
And so above the heart in the papyrus, there's the famous heart spell, which it just begins here. You can see the sign of the heart there, my heart.
Can you read that?
It's standard Middle Egyptian. He addresses his heart, my heart of my mother. Do not stand up against me as a witness and oppose me in front of the company of gods.
He's talking to his heart.
He's talking to his heart. Just keep the heart quiet. Don't let it give the game away.
Because the heart tells the truth.
The heart might tell the truth if he's encouraged too much by the judges.
The heart, physiologically, it does tell the truth, in the sense that
yes.
When you try to lie, your brain says, let's keep calm, let's not give anything away. Your heart starts thumping and you start sweating. So the heart, it really is the organ which can't help but give you away if you're not careful, which makes that practical admonition so lovely.
Absolutely.
It must have been a very well-fed monster.
Some of them look quite eager.
The ancient Egyptians did not understand that the heart pumps blood around the body, but they did recognize a quality about the heart just as profound. That when we tell lies, it is the beating of our hearts that can betray us.
I have to say, I like the ancient Egyptians. I like the fact that they see the heart as being connected with truth. Not something airy-fairy like love, but truth, that it simply tells you the truth about how you are, what you are feeling, what you think. And they were right.
As the earliest scientists began to explore the heart, what was seen seemed to reinforce the notion that this organ of truth and emotion was also at the center and beginning of life. It was the Greek philosopher Aristotle who first glimpsed this remarkable sight of the embryonic beating heart. For Professor Thomas Brand, developmental biologist at Imperial College London, what amazed Aristotle has lost none of its magic.
How old is this one?
3 days.
3 days. And you can see it fills up and empties, so you can actually see the whole pulsing there.
Yes, you see the entire cardiac cycle happening, you know. And we have here the eye, here the ear, and here the future jaw.
Aristotle could see that the heart is one of the very first organs to form in the embryo, and he recognized that the embryo could only develop with a healthy beating heart. It was vital to life.
Certainly Aristotle was the first one to realize that there is something like something forming in the yolk. And I mean, it was, I think, quite an accomplishment to see that the heart is all of a sudden there.
What did he conclude? I mean, when he saw this, did he...
Well, he saw that the heart is actually forming first, and then from the heart, actually, all the other organs are either derivatives of or are actually induced by the heart.
Really?
And this is a concept that has somehow some truth to it.
Right from the start of life, the heart is driving the development.
Yeah, the heart is very, very important. It's very essential. I mean, if an embryo, like a chick embryo, has no heart, it would stop development right away.
This is a chick, but would we see something similar if you were looking at, say, I don't know, a dog or an ape or a human? I mean, do they
would all look the same way?
Right. So this is a very basic blueprint that life has found and.
Correct. I mean, if you would see at this stage, would look at any other embryo, they would look almost the same way.
Aristotle had established the heart not just as the seat of our emotions and the teller of truth, but also the force in the body that keeps us alive. But this was also the time of the birth of philosophy, and a view began to emerge that thoughts were different to emotions, that each belonged to different parts of our bodies, our heart and our brain. This idea was promoted in the writing of the Roman physician Galen.
For Galen, the head is associated with reason, the abdomen is associated with the heart and with passion, and the lower regions are associated with procreation. So that is his way of understanding how the body functions, and that's the first time we really have a separation between the emotional heart and the rational brain.
Galen's views dominated Western thought for over 1,000 years. The heart reigned unchallenged as the seat of our emotional lives, an idea expressed in art, literature, and religion. But in the 17th century, our entire understanding of the heart changed. The English physician William Harvey made a discovery that would give a new role to the heart. Harvey was interested in how blood moves through the body. According to Galen, blood flowed like the tide, ebbing back and forth. There was no circulation. The arteries and veins were entirely separate. Harvey showed this was wrong.
Well, today what we're going to do is we're going to look at the small blood vessels in your fingers.
Dr. Art Tucker is a clinical scientist at St. Bartholomew's Hospital in London. He's able to show me what Harvey knew must be true, but was never able to see with his own eyes. That if the blood circulated, then the blood that flowed out must somewhere turn back. The arteries must become veins.
And there they are.
Oh, what, those little loops?
Those little loops.
These beautiful ghostly figures are the capillaries in my fingernail. It's in the capillaries that arteries turn into veins and blood begins its return trip back to the heart.
I can see something going around.
And that's the blood.
Am I really seeing that, or am I just imagining it?
No. Even after, I've been doing this nearly 20 years, seeing these always excites me.
It's fantastic suddenly seeing them, they seem to fill up.
Yeah, so you see that.
Whoa,
and this,
they zip round there.
and this, in one aspect, truly demonstrates what Harvey was trying to say, and that the blood flows in a circulatory path,
Yeah.
rather than flowing, as Galen said, like the tide in and back. And if you look carefully, is that the blood flows up one side, round the loop, and then returns. And that blood is on return journey back to the heart and the lungs, where the carbon dioxide will be removed and the oxygen will be replenished.
Harvey goes down in history as the man who first realized that the same organ that was understood to be the center of our emotions also pumps blood around the body. For Harvey, his discovery did not diminish the heart. It added to its grandeur. But the time in which he lived, the dawn of the mechanical age, interpreted his discovery very differently. In the mind of one man in particular, the French philosopher René Descartes, a radical thought took hold. Descartes was in love with the mechanical and the rational. And it seemed only natural to him to reimagine the human body and mind in terms of the cogs and wheels of the early Industrial Revolution.
I think for Descartes, the notion of metaphor is very important because he wants this entirely mechanical account of the world about us. And he wants to use mechanical analogies within that. He wants to say that things are like pumps, they're like engines, they're like clocks, because these are the sorts of things that fit well with his notion of the world.
Descartes' ideas recast the human body as an elaborate machine, with the rational mind now in command. The stomach and intestines as some sort of refinery where fuel is processed. And the heart? No longer the seat of emotion, nor truth-teller. Now nothing more than a mechanical pump. And it was Harvey's discovery, seen in the capillaries, that made this view of the heart seem indisputable. Zealous believers of Descartes' ideas could even dismiss the cries of pain from tortured animals as nothing more than the creaking of animal clockwork. They were becoming just like their machines, cold and mechanistic, devoid of feeling. If you want to find one moment where the new view replaced the old, it's when Harvey's work seemed to give license to applying this mechanical metaphor, not just to the outside world, but to us as well. Which was ironic because Harvey himself didn't like this new view. And that in itself is quite telling. In Harvey, it's almost as if you can see how the heart was unable to defend itself against the triumph of the rational mind. That triumph might have been lessened had Harvey and the others of his time known more about how the heart pumps blood. In particular, Had they known about a discovery made over a century earlier that painted a picture of the heart very different from the crude mechanical pumps of the industrial age? In the Royal Library at Windsor Castle, curator Martin Clayton is showing me beautiful anatomical drawings by Leonardo da Vinci. Drawings that were neglected for almost 400 years after his death. They document da Vinci's remarkable understanding of the heart.
Well, these are drawings from almost the end of Leonardo's anatomical career. It was done about 1512, 1513, so Leonardo was 60 years old or thereabouts when he made these dissections.
It was what da Vinci discovered about how blood flows through the valves of the heart that was most important. In a remarkable experiment, da Vinci constructed a glass model of the heart's aorta, the artery which takes blood away from the heart to the body. He deduced that as the blood flows through the valve into the aorta, it must make a beautiful swirling pattern called a vortex.
And then he describes how he would pump water with a suspension of grass seeds through his glass model,
Right.
so he could observe what were vortices in this chamber now known as the sinus of Valsalva, just above the aortic valve. And he surmised that the purpose of these vortices was to open out the valves.
This graceful pattern is called a ring vortex. Da Vinci understood that blood creates this shape as it flows through the valve into the heart's aorta. His key insight was that this swirling of the blood does not work against the heart, but with it, helping close shut the flaps of the valve behind. The workings of the heart had a natural beauty, totally unlike the crude mechanical pumps of the Industrial Revolution.
Doesn't it strike you as one of those little moments in history where if we'd gone that way, if someone had said, show me that again, Leonardo, and let me work on that, we would have had such a different view of what we meant by a pump. And I think what people had in mind was the kind of little drum with a stick that goes in and out, which... And that was, so when people said the heart's a pump, that's what they had in mind.
Yes.
And it's
Leonardo,
nothing
there's
like
something
that.
so sympathetic to the structure of the heart. The
Yes.
awareness that it's not just an accidental form or a crude form.
Da Vinci had realized how the movement of the heart and the flow of blood work in natural harmony with one another.
First scan starting, David.
Okay.
David, can you take a breath in, please?
Using modern magnetic resonance imaging, it's possible to see in beautiful detail the way in which the blood flows through the heart.
David, this breath hold is longer. It's about 20 seconds.
Please breathe in, breathe out, and hold your breath.
Thank you, David. We finished. Very good images. It's not always the case. We're going to get you out.
Okay.
Dr. Philip Kilner is a consultant in cardiac imaging at the Royal Brompton Hospital in London.
Is that me?
This is you,
Really?
absolutely. And
Let's have a look. Oh, God. Oh, right.
we're looking from below in this case towards the head.
So that was my heart as it was actually beating just a couple of minutes ago.
Absolutely, yes. Yeah.
Am I I'm thinking that I can see all sorts of lovely complications in the flow. Is that real, or am I
Yes,
just
no,
imagining?
that's real. That gives you a fairly genuine impression of flow. It's averaged over multiple heartbeats, so it's not quite real time. And it's to do with the tuning of the magnet that you actually see dark blood joining it.
Yeah.
But nevertheless, that blood is showing us.
But you can actually see how complicated the swirls are in there.
Yes.
It curls around, swirls here, and then it's...
Now, what's interesting is if you listen to somebody's chest, you can hear the heart sounds, often described as lubbed up, lubbed up. Well, the timing of that is like this: lubbed up, lubbed up,
Right.
lubbed up. The deeper sound, the lub, is the closure of the larger inflow valve,
Right.
and the higher pitched sound is the closure of the smaller aortic valve. which opens and closes roughly every second, faster if you're exercising.
For my whole life?
For your whole life, day and night, non-stop.
Yes.
That's about 1 million times every 10 days. It opens and closes.
What a piece of engineering.
It's stunning.
This beautiful three-dimensional scan of a patient's heart was made by a colleague of Philip's in the United States. The blue shows the blood depleted of oxygen coming back from the body through the heart on its way to the lungs. And the red and yellow shows the oxygenated blood coming back from the lungs through the heart and back out to the body.
And if I walk you around this image, if I tip it like this, we're looking as if from the left shoulder.
Yes.
And now you can begin to see vortices in the left atrium here, swirling around, and in the left ventricle swirling mainly around the anterior mitral leaflet.
So you can see it's coming in, shooting down here, curling round, and then is directed back out that way.
Yes, absolutely.
So the heart doesn't really have to shove the liquid in a way that the liquid doesn't want to go. The liquid's already heading there because of the shape of the heart.
To some extent, I think that's true, absolutely. And especially on exercise, I believe that would be true.
It's halfway between engineering and art. It's
There's a beauty to it. To imagine it all both in series and simultaneously, flowing day and night, non-stop, throughout your life. That's the most beautiful thing I can imagine.
Yeah.
It is almost as if the flow of blood has carved out the shape of the heart through evolutionary time. The chambers of the heart are shaped in such a way that the blood swirls around in the direction the heart requires. Even the vast loop made by the blood as it flows around the heart means that as the main pumping chamber recoils, this helps the upper chamber refill with the next batch of blood. And part of this astonishing beauty of the heart had been glimpsed by Leonardo da Vinci.
When you look at these two pictures, what you see here is the world of Leonardo, of Shakespeare. This is the beginning of modern science, thrilled at exploring the nature of being human. A couple of centuries later, it's completely changed. Here you have our culture, thrilled with exploring the world of gears and cogs and pulleys and ratchets and reimagining us as if that's what we were.
Mechanizing the world has brought great benefits to humankind. We have built vast cities, industry, and advanced technology. But mechanizing the heart has, I believe, done untold damage to how we see ourselves. This tendency to see things in mechanical terms is something that psychiatrist Dr. Ian McGilchrist has spent 20 years thinking and writing about.
That machine metaphor, it does do a lot. I mean, it has done a lot for us. We've built a big old mechanical world full of flashing lights and things that whiz around.
It's enormously successful at doing certain things.
Yes,
and that's very seductive.
Yeah, but what it's not good at is describing what we are. I mean, it can describe really well the mechanical pumping aspects of the heart, and that's fine. But it excludes a lot of.
We think we're understanding, but what we're doing is describing mechanisms so that we can usefully intervene in them if we need to do so.
Yes, medicine.
In that sense, they're like maps. You know, when you're driving, you want a map. You want to know where you're going to, how you're going to do it. But you wouldn't be so foolish as to mistake that map for a full description of the world. It's only telling you the things it is there to tell you about.
Yes.
And the problem with the mechanical model is it's just telling you something very important, very useful, very helpful. So it's been a great advance for us that we can see these things. But the mistake is to think that it tells us what we are.
I think seeing the heart as just a mechanical pump has encouraged us to view our bodies as machines, ruled over by our heads. And this has led us to accept that emotions and feelings, these things that were historically connected to the heart, are somehow less important. But recently, I began to question this.
If I'm being honest about it, I've spent a lifetime seeing myself as a rational person, essentially summed up by the rational mind, living in a rational world, making rational decisions. And I have emotions, and that's fine, like everybody else. Then an emotional storm breaks out in your life. You realize there's a whole side to your life, a powerful emotional life, which I can't think of it any longer as just I have emotions. I think emotions they're like the tide. You bob about on them. And if a storm breaks out, God help you. But there's no point in denying that side of you.
I think we are not so much rational creatures who happen to have emotions, but emotional creatures who have thoughts. And our hearts remind us of this. I've come to believe that seeing the heart as just a pump does not just distort how we view ourselves, but may also be fundamentally wrong. Modern science is now beginning to understand the heart in a way that is much more nuanced and complex. Some scientists are beginning to return emotion back to the heart, exploring how what we think and feel can profoundly affect the heart, even in extreme cases, causing it to fail altogether. Professor Peter Taggart is a cardiologist at the Heart Hospital in London.
If you take the English language, for example, there are expressions like died of fright, worried to death, but everybody believes that the emotion affects the heart, but scientifically there's very little evidence and very little credibility for this. So we're trying to actually bridge that gap and provide hard scientific facts about the way that it does affect the heart.
So specifically, what is it that you are actually looking for in your experiments?
Well, the ultimate goal, of course, is to look at the way that emotion may contribute to sudden death, sudden heart deaths. I mean, there are a lot of anecdotal examples, as you know, of people dying in the course of an argument or after a bereavement or some bad stress. There's several studies showing that heart deaths go up dramatically after natural disasters such as earthquakes, really? Wars and things like that.
Not dying from the actual event, but afterwards?
But just afterwards. But we don't know how, in fact, this happens. And our work really is to try and actually understand the mechanisms. How does emotion affect the heart itself to create these problems?
Okay, breathe normally. Okay, I think we could probably take the tube out. And, you happy, Peter?
Yes, indeed.
Okay. Can we take the tube away, please? And
Professor Taggart has invited me to St. Thomas's Hospital to see an experiment exploring the surprisingly complex way in which emotion can affect the heart.
a little bit more pushing.
This patient has a problem with his heart and has come to hospital for treatment. A series of catheters are being fed through his blood vessels into the heart's inner chambers.
Just going to put a little bit more local anesthetic going on this side.
The catheters contain 20 individual electrodes which will allow the electrical activity inside his heart to be recorded in minute detail.
Just going to leave that to work for a little while as well.
Before his treatment begins, whilst wired up, he has agreed to watch 2 short videos for Peter's experiment.
I'll start this dot moving around on the screen, and if you can just...
This first video is designed to relax the patient and give a measurement of his heart without emotion.
And you're monitoring the heart through the equipment.
And the recordings will give the electrical behavior on the right side of the heart and the left side of the heart. along with blood pressure and the motion of the breathing.
So you have a very clear picture of how his heart is reacting to watching that film.
In detail.
The patient is then shown a dramatic scene from the Hollywood movie The Vertical Limit, which Peter has specially selected to produce a strong emotional response.
And this is a little scene where there's a group of climbers on a cliff and the rope is pulling out of the cliff.
Right.
And the only way they can save themselves is by reducing the weight on the rope, and that means cutting the bottom person loose. And the bottom person loose is the father of the family which are on the rope.
There's too much weight here. One cam's never going to hold it. You have to cut me loose.
Everybody knows that when you're excited or stressed, your heart beats faster. But Peter is interested in something far more intricate than what happens to just the heart rate. His measurements are designed to detect how the actual beat of the heart itself can change in response to emotion.
You don't do this. I'm going to pull everybody down and everybody's going to die. You're wrong. Shut up, Eddie!
The heartbeat is controlled by electrical waves which travel across the heart, causing the muscle to contract and relax.
Is it working, your experiment?
It's getting very exciting. What we're finding is that when a person watches something that is boring and bland, nothing happens to the measurements.
Right.
When they watch something exciting, or in this case, a really dramatic scene,
It's one dead or three, Peter. You understand what I'm saying? Just think about it.
then there's a measurable change in the way that the electrical waves circulate through the heart.
Peter believes that in people with more vulnerable, damaged hearts, this effect could be enough to trigger the heart's rhythm to break down entirely.
We're going to die! How many of you are going to die? Just cut it, Peter! Just cut it, Peter! Just cut it, Peter!
It does sound like you're re-establishing the connection of emotions to the heart.
Well, I think everybody's sort of concept of the heart is that it's a pump, and when you, for example, have death, that the heart stops and that it may cease to function properly, because instead of beating nice and synchronously, the rhythm changes and the activation waves go all irregular, and it becomes discordant.
Right.
And the function goes.
And you're saying that it can be emotions that can trigger that.
This is the sort of thing that can do that in an already compromised heart. I would stress, that this only happens in very, very poorly hearts.
Right. But it sounds, and forgive me if I'm wrong, but it sounds as if you're tiptoeing back towards people who talk about he died of a broken heart.
Exactly.
Really?
Yes. Well, I think there's a whole mass of anecdotal evidence, but anecdotal evidence is anecdotal, and it doesn't have scientific credibility. Yeah. What we're trying to do now is to give, I suppose, scientific credibility to what people have known for the thousands of years.
Yes, yes. Well, I'm glad you're doing it.
Well, not before time.
I've always felt that poetry doesn't work unless it has one foot in reality. And now science is suggesting that the poetry of the heart might hold some truth.
It does seem to me we've already come quite a long way from Descartes, where the heart suddenly there was no emotion at all. It was completely stripped of any emotion. It seems to me that science is beginning to put some of that emotion back. It's not quite, the seat of the soul, but it's not an unemotional thing either.
But science is not just returning emotion back to the heart. In other fundamental ways, it is rethinking the whole relation between heart and mind, emotion and reason. I've come to Oxford to meet Professor David Patterson, who is at the forefront of this new revolution.
Yeah, so welcome to Merton College.
Thank you very much.
My research really straddles between these two organs, the brain and the heart. Excellent. Because historically they've always been viewed as islands to themselves.
Fantastic. I want to hear about this.
Professor Patterson's research is helping challenge the traditional view of how the heart and brain work together. The brain is made up of billions of neurons and is able to influence the heart rate by sending messages down the different nerve fibers, the wiring of the human body. When the heart receives signals from the brain through the sympathetic nerves, it pumps faster. And when it receives signals through the parasympathetic nerves, it slows down. On its own, this appears to fit with the picture of the heart enslaved to the brain. But the true relationship between the two organs is far more nuanced.
If you look at a heart,
You happen to have one with you.
and I happen to have a heart in my pocket, which all good physiologists carry around with them. But the traditional anatomical view of the nervous system in the heart is that you have these major two nerves coming down from the brain.
Which is just telling the heart what to do.
Speed up, slow down.
Yeah.
But in the heart itself, you have around 10,000 or so of very specialized neurons that sit there. And these predominantly lie around the right atrial
Not just
surface.
nerve cells.
Not just nerve
You're
cells.
using neuron advisedly.
That form networks.
Okay.
And that begs the question.
Yeah, begging many questions.
Well, what is their role? Why are they there? Why has nature put them there?
Yes. Why are you the first person to tell me this?
Well, it's not established in textbooks, and there's
But why not?
And there's a very I think the textbooks need to be rewritten, and they are being rewritten.
Right.
It's astonishing to think that neurons, the very cells that make up the brain in our heads and give us the ability to think, are also present within the heart. And there are so many of them that these neurons have been called by those who study them the heart's little brain. Much about the heart's neurons is still unknown, but one thing is clear, that the brain in our heads doesn't simply control the heart, but works in partnership with it.
Right. Oh. It's a little bit different from college.
What you're looking at is a section of tissue taken from a rat's heart. It contains most of the neurons that make up the heart's little brain. The tissue is being kept alive by a solution of nutrients and the bubbling oxygen. And if you look closely, you can see that the tissue is beating of its own accord.
So this is just a little bit of that right atrial tissue, and inside there are these neurons.
Right.
And in fact, what we see here is that the tissue is beating by itself.
So is that it looks like a heartbeat, is it?
That's right, it's very similar, but it's
is.
an actual contraction. So this is beating at about 180, almost 200 beats per minute.
Professor Patterson is going to show me that by sending an electric signal to the heart's little brain, that little brain can then slow down the heart rate. This mimics how the brain in our heads asks the heart to slow down, a process that relies on the neurons in the heart.
We've got a very small electrode sitting over by these neurons, so we're going to excite them.
I get to press the button?
And then look at the trace.
I'm a little nervous about it. But...
Yeah.
Pick it
Yeah,
up,
see?
pick it up. Oh my God.
See that? See it slowed down?
That's dramatic.
So what you're doing is you're activating the neurons.
So I sent it a little
You sent it like an
mental
impulse
signal.
Yeah, mental signal.
Oh, and it's going further down.
Yeah. Because you're maintaining the
I better
stimulation.
switch it off.
So turn it off, and then the parasympathetic nervous system
It's
now
going back.
is now back off.
Back is coming.
And up it comes again.
Isn't
it?
It's fast too, isn't it?
It's very quick.
Look at that. I
In
switched
fact,
it off
it happens within about a beat. What we've done is completely taken the brain out of the picture.
Right.
We've just electrically excited those neurons.
Yes.
So right down at the
The
target
neurons
tissues,
in the heart. And now they're taking over.
They're taking
doing
over,
it.
and they're releasing the chemical messengers to then slow the heart down.
So in a way, that's demonstrating how much of that neural control is in the heart.
Is in the heart itself.
Because we evidently don't have a brain. We have a small...
stimulator.
Small, grotty-looking pile of simple electronics. That's not a brain.
That's right, yeah.
So the decision, using the word slightly metaphorically, is happening in there.
It's happening right in there, that's right. Completely devoid of the central nervous system.
That's rather impressive. And it looks great.
Yeah.
This shows the extent to which it is these neurons in the heart that control what the heart does, not the brain. Professor Patterson's work is revealing just how complex the little brain and the heart really is.
See if we can see some of the heart cells beating.
Well, so
there,
something pulse there.
Okay.
These are the neurons that make up the heart's little brain. They live side by side with the cardiac muscle cells in the heart.
They really are a unit then, aren't they? I mean, it's not just, here's the heart doing everything the heart does, and then we've just got some neurons just watching what's going on. There's an active partnership here.
Oh, yeah, no question about that. We need to understand this. It's very poorly understood. The detailed neurochemistry, the detailed electrophysiology. We're only really starting to scratch the surface of this network in the heart.
Gosh, we are a long way from just playing with the plumbing of a pump.
Much more complex than that.
I suppose I feel optimistic having talked to Professor Patterson, because I do have to admit that after the first day I felt quite concerned. And we got such a telling off that I thought, well, maybe this film really has gone off in all the wrong direction. Maybe what we're trying to say is just silly. But having talked to Professor Patterson, I feel that there really is something important, something scientifically true, but also something important that we are trying to say. I feel good about that.
Modern science is now painting a picture of the heart that I believe is much closer to how we really are. The heart is a pump that does respond when the brain asks it to, but it is not enslaved to the brain. Its relationship with the brain is more like a marriage, living in partnership, with each dependent upon the other. But most importantly, it seems to me science is now restoring to the heart something of what rightfully belongs to it, our emotions. Because it is not just thoughts that govern our lives.
Well, a couple of years ago, my wife became profoundly depressed, clinically depressed. And the person I fell in love with, the person who I've lived with my adult life, is it's gone. And it's a very painful thing, not just rationally painful. I never knew what that phrase, my heart ached or my heart broke, it's just poetry for me, but it isn't anymore. I just suddenly was confronted by a question I'd never thought about this relationship between the life of my heart, the emotional life and the emotional centre of it, which when it was fine, I never thought about it, I just took it for granted. But something went wrong with my wife's mind. And it's hurting my heart.
Can you make sense of the most emotionally difficult things in your life simply by having a rational think about them? This is what I've tried for the last 2 years, and I can tell you, it doesn't work.
When, you know, this illness took Sarah away from me, I sort of felt, well, it's so easy for the rational mind to say, look, it's a rational world and you have rational thoughts and you keep those silly emotions at bay because they get in the way, but I don't have a clear, I can't sum it up in 2 or 3 rational sentences.
But what makes you think you should have to sum it up in 2 or 3 rational sentences?
I don't know. That's a good question.
Perhaps
I don't know. I thought I should be able to. That there would be a.
Well, you're talking about the most mysterious and complicated things that we experience.
Yeah.
And it's unkind to yourself to think that you would be able to sum that up in 2 or 3 sentences. And indeed, it's not likely that we would ever be able to sum up such things in that way.
I'm not going to find the way forward through an emotional storm just by consulting the rational part of my mind. I feel there's a whole other side to me, which unless I give it a voice, unless I listen to what it's telling me, I'm not going to make it through. And that's my heart. But what does it mean to follow your heart? I would like to think that the heart's influence is as it has always been imagined by the poets, that it makes us kinder, more compassionate people. The final thing I want to explore about the heart is how it can affect the mind. In this experiment, images of frightened and calm faces are being shown to me for split seconds. Some in time with my heartbeat, and others out of time. And I'm being asked to judge the intensity of the face. This research is being carried out by Professor Hugo Critchley and Dr. Sarah Garfinkel at Brighton and Sussex Medical School.
How was that?
Stressful. No, it was quite weirdly intense. And the second one started out fine.
Yeah.
And then got more worrisome.
Okay, so we can come through here now.
What Hugo and Sarah are interested in is whether my brain experiences the faces differently if they are shown to me in time with my heart.
This is your intensity ratings here.
Right.
And if fear faces were out of sync with your heart, then you rated them as less intense. If they were in sync with your heart, then you rated them as more intense. And if you look at the other categories, there was no difference of heartbeat. So neutral faces, it made no difference, exactly. So the only time the heart was influencing your emotion ratings was when it was an explicit fear face.
Right.
The results show that when frightened faces were shown in time with my heartbeat, I perceived them to be more frightened. In other words, how my mind processed the fear faces was affected by my heart. From the brain scans, Hugo and Sarah are able to pinpoint the exact region of the brain that is affected by the heart.
When your brain is processing fear in time with your heart beating, we get this great massive activity in a region of the brain called the amygdala, which is known to be the threat processing region of the brain. Just showing that the amygdala processes fear in conjunction with the heart's signalling when it's beating.
Does that light up more when it's in sync with the heart?
Absolutely,
than when it's
yes.
not? Really?
Yes.
But the experiment had an unexpected effect on me. Although I was being shown frightened faces, it was not fear that I felt, but concern. The faces were reminding me of someone I care about.
It was quite an intense experience because I was looking at those faces and feeling worried about those people. I mean, not those people. I was looking at those faces. It was reminding me of someone I care about and thinking about their pain or their sadness, and that was what made it very intense for me. But is that really what was going on?
Certainly, the way we interpret other people's emotions is very much influenced by our capacity to embody their emotional states.
If I see someone in pain, something bad happens to them, and you're saying that my heart helps me to create some
understanding of them from an emotional level, yeah, absolutely. So certainly this emotional system is very much tuned into emotions like compassion for other people, empathising with people's emotional states, as well as producing the kind of shared joy and positive emotions that bond us socially.
That's fantastic. So that phrase, I feel for you.
Yeah.
You do. What you're telling me is my heart is able to make that true, that statement.
The heart is certainly a big component. I mean, I consider the heart to be one of the main channels of that kind of information.
It seems that the heart beats not just with our own emotions, but also with other people's. It is our hearts, working in tandem with our brains, that allow us to feel for others. And painful though it might be, at times, to experience that compassion, it is ultimately what makes us human. For me, compassion is the heart's gift to the rational mind.
That the things I hoped would be true about being human, I'm reassured that they are true. And that the things which I hoped would be how we work and the kind of creatures we are, they really are. You can experimentally see that is how we work. And it does underpin the thing about us which I personally feel is what makes us a worthwhile species, that we can feel compassion for other people. I'm not really hugely impressed that we can build faster jets, but that we're made in such a way that we can feel someone else's pain and feel compassion for them. I think that's fantastic.
In the end, this battle between the head and the heart to decide what's the best part of us leaves no triumphant victor. In reality, we need both. The heart may be more than just a pump. It may help us to care for one another, but it is stuck in the present. It is only the brain that can imagine a different world and invent it. But if we want that world to be a better world, then surely we also have to listen to the heart.